Specifically, what we'd like to do is achieve a nice printout of our values. But first, let's see how the two-string method works. And to see how it works, what I'm going to do is I'm going to replace all of these with a code that does this. Just print variable p1, p2. That's all I want to do. Just print out these. But I'm not invoking any particular methods, as you can see. I'm not getting an ID, I'm not getting a name, price. Run this code. This is what we'll get. Now, what we need to find out is how that's happening, why we are observing these particular printout. So we're looking at print plan. Yeah, print plan printing is objects. So if we navigate to the declaration, this is what we're doing.
Por favor, Karina, pegue pastel, por favor.
The first thing that happens inside the print plan method is this is actual source code here, plus print screen, which is doing. First thing that happens is that apparently the object is passed to string value. So that's the takes the object checks if it is and if it is now, just returns the word now. It's just a string, right? Otherwise, it takes the object and invokes the method to string upon. And what does the toString method? Let's go to declaration of that. ToString method gets the class name, appends the @ sign, invokes the method hash code, and presents it as a hex string. So there's your class name, there's your @ sign, and there's the hash code presented as a hex string. That's precisely what you observe in the printout. So this is the chain of the method calls when you do print plan. First thing it does, asks the string to convert to string, which calls the method to string, which is the method of the object class. And remember, object is a multi-parent of all other Java classes in the entire Java class hierarchy. So any Java class apparently has the method to string. Yeah, no, that's what you're actually invoking. In a sense, I suppose you could have done it like this. You could have said p1.toString, and it just do it yourself. But there's no difference really. I mean, you just convert it to string. The output is just the same as if you wouldn't call the method to string, because the first thing that happens in print plan is that it attempts the conversion anyway. So that's the default behavior, right? This is what the method to string of the object class does, and printlen simply prints what it returns. How about once we've investigated what that default behavior is, we understand what it's meant, how about we will actually override the method to string in our classes? Let's go to the product class, override the method to string, and just, print the information about ID, name, price, rating, whatever we want. Okay. Let's go to the product. And there is an override method which allows you to override just any method, but there's a special one for toString because kind of so often that makes sense to have dedicated method. So overriding process, clicking generate. So there you go. That is the version of the method for the project. Yeah, so we override the default behavior of the object class. Okay, well, it's here asks you to rearrange it a little bit, just to print out this comma separated sort of version of the product represented as text. So let's do that. Okay. And there's something else that the nodes are talking about. If I will accidentally type this in, for example, in the wrong case, because I have an override annotation, the compiler will prevent my code from compiling. Try to compile it wrong, because it will say, this isn't the method toString, this is just some other method. If you don't put override annotation, because then the compiler has no reason to complain. The compiler just says, well, you just create this method. Now, technically, to override a method, all you need to do is match its name, return type, parameters, exactly as the parent in this object class defined. So you don't really need override annotation. That's really optional. But as I say, if you made an accidental typo, override annotation will kind of trigger the validation and will ensure that you, well, don't leave the code with accidental typos. So it's okay, so you have this method toString now, and yes, that was the first test. Just run the application. So no changes in this control whatsoever. Just keep running. And there you go, you immediately got it. Because you are essentially, remember, call a method toString. That's what's happening. Right? And of course, because you're all reading that in the product class, remember the lowest available implementation down the hierarchy is automatically low. So when the printlen calls a string value of, and string value of calls the toString method, it's actually calling that toString, which is this new code, because that's lowest available down the hierarchy for the product class. Okay, great. So we don't really have to list all of these properties. We can just print. Moving on. So now let's go one level down to the food class and repeat the process. In the food class, we would like to override the toString method as well. Sure, let's do that. So we're going to the food class and just insert code, override toString. So this is the code that was generated by NetBeans, and probably what you want to do is actually replace this logic. And the suggestion that is made is actually reuse the superclass code. So call super toString, which is the version of toString that you just overridden on the product. And then append best before date to that. Okay, so that is right. So what's going to happen? See, here's the product inspection. Now I'm printing these for various products. Only one of these products is food, P3. And for that instance, for P3 instance referencing food, the method is obviously different. The toString method has been changed for this particular instance, right? For the P3 instance, because it's referencing a different class, it's referencing food class. So you could see that the lowest available implementation of the toString method kicks in automatically. And for all other instances, well, that would be the version of the toString provided by the product. Drink doesn't override it. So the drink basically recycles whichever behavior is available for the product. The string does not override toString. So generic behavior is used. And food does. And notice that the food recycles whatever logic the string toString method of the product did, and sort of augmented that with an extra condition as before date, but otherwise pretty much left it. So it's just that extra bit that the food class methods. Yeah, okay, so that's nice. We have this kind of polymorphic behavior, right? And we've observed the reason why that's the case. And also notice that all of these variables are declared as just one. You don't really have to change the definition of these variables. Now, actually, do you know what? Let's just make a point out of it. And run. And it works. The lowest available implementation down the class hierarchy is automatically invoked. And as you can see, even though my variable P1 is declared as type of object, the toString method that's actually being invoked is that one of a product, so it works perfectly fine. Of course, you won't be able to go to variable P1 and call anything but the generic methods that are available for the object. Yeah, sure. For that, the variable has to be of a more specific type, like product. But you see, and then of course you see the product specific methods. That's not a problem. Yeah, now you can see this get discount. But you see, in order to call the method toString, which is the one we're overriding now, and the only one we're really using directly. That's the only method we're actually invoking. We're not really calling any other methods about these products at all, because everything is initialized from constructor, and we're not really invoking any other methods. So that basically means that how you declare this variable is pretty much irrelevant, well, in this situation. What's important is what you are allocating in memory and reference. That you allocate product, drink, food, and therefore you get appropriate behaviors from the reference. And it really doesn't matter how you reference it. Product reference is generic. That's fine, because you're not using any food-specific methods. See, that's my point. P3 dot, I cannot change that date or get that date because I don't have it on the P3 object. Yeah? Get P3 is referencing the food, so to be able to do that, I really have to do the custom of P3 to food type in order to be able to call any food-specific operations. What was that? Yeah, that's before. Yeah, that was a food-specific operation. I'm never calling any of these specific operations, so my references can stay generic. That's fine. That's fine. Now, let's go back to the practice. The next thing we would like to do, so we played around with a toString, and that's typical generic behavior, right? And we talk about the fact that no real custom of types is real. The next thing we'll look at is how do we compare products? What do we consider to be the same product? And to introduce us to this conundrum, we'll create a couple of new products in the shop class. So that would be product 6 and 7. And they're food and drink, but here's the thing. Notice they both are 104. They have the same ID. I know it's strange, but nevertheless. And they actually have the same name, chocolate. Now, I suppose the chocolate can be food and can be drink, right? So relatively makes sense. It looks like all of their properties are the same, except of course the food has this expiry date thing, which drinks don't, but that's just the way we design food class. But all the properties, ID, name, price, everything, rating, yeah, all appears to be the same. So here's an interesting question. Should we consider them to be the same product? Well, if you just compare them with equals method, they will not turn out to be the same. Just do the comparison and print out. Then we'll print out the boolean true or false, right? So let's see what it is. It's false. Yeah, they're not the same. The result is false. Why they're not the same? Well, because there are two different objects in memory. What is the equals method doing?
Yeah.
By default, inside the object class, just compares references. So, is that the same reference? No, it isn't. These are two different objects. You use a new operator twice. Yes, it's two different objects. Okay, so they're not the same in terms of, physical sort of reality of which object that is here, right? And we just discovered that's because that's how the equals method works. In the object class, it just compares references. The only plausible scenario when that would return true is something like this. If you'd say that P7 equals P6, oh yes, and then the double equal sign that is used to compare them in the object class in the default version of the equals method here, will yield to true, because there will be now the same reference, right? Oh yes, that's true. But that's not the case, then they're not the same object. Okay, so that's the logic of the equals method of the object class. But I guess what we could do is change it.